People can trickle in, and we got this recording as well. So, all right, everyone, welcome. This is the NoirHack 2025 kickoff. Really excited you're all here. So let's just jump into it. So let's just get straight to it. NoirHack is for you. So this is your space for the next 4 weeks, your chance to dive into Noir, to learn, to collaborate with other builders, to build things that matter for privacy, to make connections, and maybe win some prizes along the way. So what's the plan? What is NoirHack? NoirHack is a 4-week fully online sprint focused on building privacy-preserving apps with Noir, running from right now to May 9th with demo day May 12th. So the first couple of weeks will emphasize learning, exploring ideas, and checking out our workshops. Weeks 3 and 4 are heads down build time, but I want to clarify you can start coding whenever you feel ready. The end goal is demoing your project for feedback and for prizes. So we've got a large and diverse crowd. So we have 3 informal tracks to help you find your footing: beginner, intermediate, and advanced. Beginner is if you're new to Noir, new to ZK, focus on learning the core concepts, building a cool and maybe viral even demo, and asking lots of questions. Intermediate is if you've got some experience, you can aim to build a solid project, connect with others, maybe build something grand prize worthy. And advanced is if you're deep in the space. This is where you push limits, build foundational projects that could become companies or products, and mentor others. So all of this is on our start page for more details, the noirhack.com/start page. So immediate next steps, what to do right after this call. First, get in the Discord if you haven't already. Go to the Get Roles channel, grab the NoirHack participant and your experience level track. Do this. It's actually really important. It's how we'll judge your projects building up to demo day and engage with you as the program continues. And then second, jump into introductions. Post who you are, what you're about. I created this channel to just streamline the introductions. I've added a pin message as well to lay out like how to do your introductions. And then third, for beginners, your first clear task is on the start page. Complete one of the intro tutorials. And we also have a proof of proof channel, which where you can post your first proof. And then fourth, for intermediate and advanced, check the dev guide on the start page and start looking on the team formation channel. And so let's take a quick look at week 1 goals for each track. So for everyone, check out the workshops this week. They'll be key. And also join the team and track session on Wednesday. That's tomorrow. Beginners, finish that tutorial, post your success in the proof of proof channel, and ask questions and help. Intermediate, start sharing ideas, needs, and team formation, connect with people, try to help answer questions and review the core libraries, some of which will be in the workshops even this week with ZK Passport presenting on Friday. And advanced, connect with peers, mentor and help, post your ideas, and you're looking for members' needs. That's all in the pinned message in team formation, and then start thinking about teams and building out an idea. Again, the noirhack.com start site has the full list of all of these. So um, Discord will be our main communication hub. So please use the dedicated NoirHack channels, announcements for all official stuff, notifications about any workshops, or any other things that you need to be aware of, introductions to share more about yourself, help, and then team formation, and then proof of proof and other channels for any specific purposes. Check the pin messages often and be sure to use your track roles and ask questions and engage with other builders and our DevRel team as much as you can. And second, the Notion site start page. That's www.noirhack.com/start is our main info hub. All relevant documentation, guides, schedules, and eventually workshop recordings will live there. So think of that as our source of truth document. We'll keep it updated. So team formation and tracks. Teams are an important part and a big part of how you can take a hackathon project and turn it into a full-fledged company or product. So we'll talk strategy in the teams and tracks session tomorrow. For now, use the team formation channel and check the pin message for format. And working solo is also cool. Just focus on building, on laying out a good idea, stay engaged on Discord, and stay checking the Notion page and start building. And consider getting feedback from other builders and from our team, as ideas will only get better and more refined if they're challenged. We'll also share more tomorrow on how you can use your track more effectively to engage with other builders and with our team. So, what's next? What happens right after we close this call? Um, First, during this call, Arnaud here will talk a bit more about the bigger picture and why privacy is so essential right now. Then stick around for the first Intro to Noir workshop with Kat. It's aimed at beginners, but could be a great place to fill any gaps you have in your understanding, even if you're intermediate or advanced. And then second, we have tomorrow where we'll have the teams and track session. So don't miss it if you're thinking about collaboration. There'll also be more details on how to leverage your role a lot better. And then we'll also have our first ecosystem workshop with Michael, an exploration engineer at Starkware, who go into verifying Noir proofs on Starknet. Thursday will be the deadline for show and tell, which will be a great way to engage with our team, building up the demo day, and to find other teammates. It'll evolve as the program moves forward. So be ready to share and present whatever you submitted. It's all right if it's just an idea right now, or if you're a beginner, we're interested in just seeing your creativity and engagement. And finally, this Friday, we'll have our first library workshop with Theo, who's the co-founder of ZK Passport, who was actually recently featured in Vitalik's post on privacy. So it'll be a great way to start learning to build with this first building block. And again, all of this will be communicated in the Discord and laid out in the Notion site start page. So now to talk a bit more about the bigger picture and why privacy is so essential, I think literally right now, I'll hand it over to Arnaud.
It's always a little a little bit daunting having like a Vitalik tweet staring at you while you're talking about something. Um, before I kick off, like why I'm excited at this present moment for Noir and for privacy and the whole kind of privacy ecosystem. I just want to say like we have about 100 people on the call now. We had more than 600 people asked to take part in NoirHack. If you've joined the call late or if you are watching this on a recording, like we've done this in a way, hopefully, where if you put in effort to meet people, to like get feedback on ideas to get better over the 4 weeks, you'll get quite a lot out. But there's just a lot of you, which is amazing. We won't be able to hold hands for everyone. Do like try to reach out to the team if you're stuck or if there's anything that you need help on. But I just wanted to say that this will be as good as as what you put in, essentially. Like the more effort, the more vibes you put in, the better the whole month will be. To get back to what I was actually prompted to talk about, which is why I'm particularly excited. I it's always a bit of a risk for me to go into a long monologue about this. So I'll try to keep it short because I know there's hacking to be done. But in the 90s, we used to speak about cyberspace. We used to speak about this place, this digital place, which was going to be a frontier where we could maybe get out of the mess that we were in everywhere else. And gradually, over the course of, let's say, the first 35 years of a proper internet, we stopped talking about cyberspace, right? We started talking just about the internet and about memes, and for whatever reason, our ambitions decreased. And I remember feeling quite stuck in the early 2010s because I felt like there was all this leftover promise for what we'd started in the 90s but never really accomplished. And that's the context in which I encountered the kind of Ethereum white paper. The 2014 white paper, we're going to get to the 10-year of the launch of Ethereum, but like the very first white paper was in 2014. That's what it promised to me, right? It was to get back at a level of ambition that we had lost sometime in the early 2000s about what cyberspace could be. Cyberspace as a frontier, as a jurisdiction that was not just the US or Europe or Argentina or whatever else. It was a place with its own culture, its own economy, its own rules. And Ethereum in 2014, I really thought was going to be it. Um, I still think it is going to be it eventually. But what we realized when we started really pursuing this idea, when we started in 2017 with what became Aztec, is whenever you try to do anything real on this new platform that had deep down all this promise, it was only one or two steps after getting started that you'd hit this fundamental barrier, which is real life, real things just can't happen if everything is forced to be fully transparent. Enforced transparency that public blockchains, that's kind of the rule of public blockchains, right? This enforced transparency. It's not just because there are things that are we have things to hide or what have you. In your daily life, that is not something you would accept, right? And that's what we found out in 2017. We went to all these both businesses and funds and potential customers, and they just were quite keen on the pitch that we gave them at a high level. But as soon as we started describing Ethereum, everything shut down because you just can't do the things you want to do if you have to reveal to the world at all times everything. And, we had the brief hope in 2017, 2018 that someone else would solve this problem for us. We just wanted to build products. We wanted to build things that bring people to this new cyberspace jurisdiction. But we quickly realized that there was just no one there, right? We kind of had to do it ourselves. We were very, very pragmatic along the way. And like in retrospect, we really tried to go the shortest distance at every step to try and get privacy that was workable, that was easy to use, that was extensible, that was useful, that was real privacy. And it took us, seven odd years to get to where we are now, where I think for the first time you have people who are taking tools who are not cryptographers. And I really, really hope that of the 600 people who've asked to take part in NoirHack, at most 20 are cryptographers. That is what we built for. And we're starting to see people actually take our tools and not have to understand the underlying cryptography and build products on top of any public blockchain or private blockchains like our own layer 2 Aztec, and build really, really powerful applications that are not limited by the enforced transparency that public blockchains have kind of thrust upon us so far. I was having this conversation a couple months ago with a friend who I think had also been quite enamored with the promise of blockchains quite early on, but had soured on it quite badly. And it's only when I started talking to him about the things that you can now do with zero-knowledge proofs and with private state and with tools that are just on the horizon, like collaborative snarks, or that are getting more and more practical, like Teas, and hopefully in the kind of long-term future, things like FHE, that I saw him see the promise again. And so that's why I'm excited about NoirHack. I think to me, it represents a real test, but also just something really exciting about the state of the tools that we've built over the past 7 years that we've and the team has poured just an incredible amount of effort into making practical and performant and easy to use for people who are not willing to just hand code circuits like we were back in 2021 or 2022. But it's also a real test for us, right? It's a test of that effort. It's a test of whether everything will work. And I'm sure some things will break or will not be quite performant enough or what have you. But ultimately, I'm just excited about the prospect of finally getting back to the original promise of blockchains, which is actually the original promise of the internet, of cyberspace, right? I think we finally have within reach this idea of creating this new jurisdiction, this frontier for the world as it currently exists, that is actually this jurisdiction that is adapted to the world post-internet, instead of always having to rely on these jurisdictions that I think at this point are quite obviously stale and no longer fit for purpose. So that's what gets me up in the morning. And I'm so grateful for you all dedicating time over the month to use the tools to build things with it, to push the limits. If things break, just do please let us know. If you're confused about things, reach out to either the team or each other. And I'm incredibly excited to see what comes out of this month. Thank you all.
Hey man, thank you, Arno. I don't think I have the yeah, I don't have the cool animations. But yeah, thank you, Arno, for the kind words and for sharing the broader context. And yeah, I think I agree that it's really what you put in. So real quick, I think I'll share the Notion page, which is what you should look at immediately after this call, or maybe even during this call, especially if you missed parts of the presentation. And then we'll go into Kat's workshop, which will be a great intro, even if you are intermediate or advanced. But let me quickly just pull up the start page. So right at the front, the very beginning, you have these checkboxes on your side. You should be able to click these. So again, the first few things will just be to join the Discord, to set your role, and then to introduce yourself. And then there is a weekly action plan. Each week we'll update it with specific tasks that you can complete based on your experience level. And then there's also this guide for more details on how to get started, ideas, and it links out other resources. And then, yeah, let's look at week one. So for everyone, join Discord, set your role, set your track role, introduce yourself, review the resources, check out the workshops. We're about to start one right now. And also share your journey if you'd like. And then for beginners, I really encourage you guys and then really anyone to participate in this proof of proof channel where you can share your first proof with a screenshot or with a tweet and try to ask at least one question in the help channel in Discord. For intermediate, start posting project ideas, connect with other people, help answer questions, and review the core libraries. Again, we'll have a library workshop on Friday with Theo from ZK Passport. And then for advanced, start getting feedback on your ideas. I would say like this is the main thing that I would emphasize, and really like what makes or breaks, what turns an idea from just some kind of like seed to what could potentially be a protocol or a product or business. So really try to take advantage of the program and get feedback not just from our team, and later from our VCs that will be a demo day, but from other builders, and try to refine like what it is that you're working on. And then finally, the calendar is down here, other resources, and then the Friday show and tell. So this will be one way to get that feedback on your idea or on what it is that you're building. So try to apply by this Thursday. And yeah, we'll have a cool set of different options around how we'll share what it is that you guys have submitted, and you may even get to present before demo day. But yeah, I will leave it there and then I'll hand it off to Kat to kick us off with the intro workshop. Thanks, everyone.
Yay! Thanks, Rafi and Arno. It's always so amazing to come on the calls and hear Arno speak about privacy. All right, let me see if I can share my screen here. Hold on, my privacy settings are off. I got it. I'll be back in a second, I think. Hold on a minute.
The classic Zoom permission shuffle.
Yeah.
In the
2
meantime,
seconds.
while we wait for Kat to come back on, I know that a lot of you have already found the Q&A tool on Zoom. Just because there's quite a lot of people, we couldn't open up the main chat, but feel free to ask questions in there, and obviously in the Discord as well.
All right, I'm back. Sorry about that. Can everybody see the slideshow?
Yep.
Okay, cool. So, welcome to NoirHack, everybody. This is super exciting. I think this is the biggest thing we've ever done for building with Noir. It's kind of nerve-wracking, but I'm really excited to see people dive into this for the first time and see everything we've been building over the past few years and actually build something really cool with Noir. There's so many different ideas, and it's going to be awesome. But today, I'm just going to talk about a little kind of introduction to zero knowledge in general. This is a super, super beginner workshop. So if you've never touched Noir before, this will be good for you. I just kind of want people to like understand ZK, understand Noir. We're gonna install Noir from scratch and just write a circuit and prove it, verify it, and do the whole flow. So you can see how all that works. We'll explore like a little bit about all the things that Noir has to offer and different things you can do with it. And then we'll also look at like generating a Solidity verifier, which you'll probably be using in your projects. So you can actually do verification on chain. So for those of you who don't know what zero knowledge is, it's basically just a proof about a fact that doesn't actually reveal the information about that fact. It's used for privacy. It's, you know, there's lots of examples. I think we have ZK passport coming in on Friday, and you can basically prove anything about your passport, like where you're from, your date of birth, or just that your like age is above a certain thing, or your name or your last name or something, without revealing any other information about that passport. And it's verifiably true, which is pretty freaking cool. Kind of like a way to think about how it works is that you've got two different entities involved in this. You've got a verifier and you've got a prover. A prover is just going to be you. You're just proving something, you have all the information, and you're giving some sort of like, this is what it is. And then a verifier takes that proof and runs some complicated math on it and verifies that the proof is legit. But a good way to think about it is, say you've got this verifier who's got like two balls, a blue ball and a green ball, and the prover just wants to prove that they know the color of the ball, without like revealing how they know it, pretty much. So the verifier is going to throw a lot of challenges at the prover, like, okay, tell me this, I'm going to verify that all this is actually true. And say like he's got the balls behind his back, and he's like, this is a blue ball. He takes out a blue ball, and the prover says, yeah, that's blue. And then the verifier like shuffles it behind his back and takes out the other ball. And then the prover says, yeah, that's different, or it's the same as the previous ball. And like he could just be guessing. It's like 50-50 chance of whether or not this prover actually knows it. But then the verifier is going to do it like hundreds of times, thousands of times. And eventually you're going to pretty much figure out like, yeah, prover knows the color of the balls. So that's kind of like what we call an interactive proof. But now we've got to the point where we can do all this in like one. So the verifier bundles all of these like challenges into one big challenge and sends it to the prover. The prover does it all in one go and sends it back. And then because of that, we don't just need only the verifier to verify it, but like anyone can actually verify, because it's just like one thing that you have to run rather than this interactive thing. And that's called a snark, which maybe you've heard this word. Lots of people are talking about it everywhere. And the important word here is succinct, so it's small, and it's non-interactive argument of knowledge. This isn't like super important when you're building with Noir, but I think it's useful to just be aware of, because there's loads of different words that you're going to bump into when you're trying to build with stuff with Noir. And there's loads of different types of snarks. There's just like different optimizations, different reasons you might use them. And the cool thing about Noir is that you can use all of these different like snarks to generate proofs. So you may have heard like Groth 16 or the word plonk or the word like honk or ultra plonk or ultra honk, especially if you're on like crypto Twitter and people make fun of these words a lot. Pretty much all they are is they're different types of snark proving systems. And Noir, it's its own language, like it's this language, but it's really, really universal, and you can use any sort of proving system with it. And it's really like good to think about how these things are decoupled. So when you're writing something in Noir, it compiles down to abstract circuit intermediate representation, which then is like fed into the virtual machine, and that translates this ACIR into what like the constraints for whatever proving system is specified. So we're going to be using in this workshop Berettenberg, which is the one that Aztec is building. And you can use different proving systems with Berettenberg, but we're going to be using UltraHonk. If you want to use a different one, like if you're doing a lot of on-chain verification, you might want to use a different one that has different optimizations. Let us know in Discord and we can talk through that. But yeah, like the flow of how this kind of works is that first thing you got to do is write a circuit in Noir. This is an example of a circuit. Like it literally just looks like code. Noir is really based on Rust. And hold on. It really just feels like writing a Rust program. That's kind of what we're trying to do here. And what this is doing is it's taking in X. Everything is private by default, so you don't have to specify that X is a private thing. It's taking in X. It's also taking in Y, which is public. So that means the verifier has Y, and it's asserting that they're not the same. So you can assert that they're the same as well, whatever. We'll write this in a second so you can have a look at it. This field is just like the default field for whatever proving system we're using. So you can kind of, the way you work with fields is like pretty much with like unsigned integers, is how they look. But yeah, you use these for a lot of different things that you'll be doing with Noir. Then you're going to compile it down and then you can execute it. And when you execute a circuit, you pretty much are just like assigning the variables to it. So say we would say like X is 1, Y is 2, and then we execute it and then we're like kind of running it like a program. Like this is actually, executable, this X and Y, and this is the variables that I have assigned. And yeah, that's called a witness. So like saying that X is 1, Y is 2 is my witness for the circuit. And once we have our witness and we have our circuit, we can prove it. So we specify whatever proving system we want to use, for example, Berettenberg, which is the one we're going to be using. And then we pass that to the circuit and we pass our witness as well. So we pass it like X is 1 and Y is 2. And then we can verify it. So we give that proof over to a verifier. That can just be a person. There's no like information in this proof. It's just like a string. You can pass this, you give it to anyone. And then they are going to run computation on it to verify it. And then you've got a verified proof. A verifier can also be like a smart contract, which is cool. So if you want to follow along, you can do that now. There's also going to be recorded. You can follow it later. Or you can just like have a look at this repo. It should be pretty laid out pretty well. There's like readmes and stuff, so you can just follow it from there. But you can go here. This is my GitHub. What is Noir? Wait, is that what it's called? Yes, okay. This QR code will go there as well. So it just looks like this. We're going to be going from starter, starter, and then just like making our way up to main. There's multiple different steps here. They each get a little bit more advanced and teach you something else. And that's what we're going to be going through. So I have it here in my thing. Step 1, step 2, step 3, and step 4. So if we start with step 1, there's nothing in here right now. We've just got to readme to like install stuff. And actually, I'm not going to run this. But if you go to noir/line.org, click read the docs, and just go to this quick start, getting started quick start guide. This is going to install Noir up, and then you can use that to install Nargo, which is like the way that you're going to install different Noir versions. So if we run this here, we can see that like it's installing Noir up. I would run Noir up. I'm not going to do it, but that's going to install Nargo. It's really similar to Rust, if you're familiar with that. And then we also want to install our proving backends. We want to install Berettenberg, and you can just run this. It's like the same thing. You run this thing that's going to install BB up, and then you run BB up and it will install Berettenberg. So got to do that. That's also in the README in the repo. So I can see that I've already installed it. If I go Nargo version and BB up version. Awesome. All right. Step 1. So we're going to start from scratch. We're going to make a new program. Super, super simple. I'm going to go into step 1 here and just do Nargo new and give it a name. So I can call it main. And then you'll see that there's a different directory that's been created for me here, this main directory. It's got a source directory inside of it, main.nr. This is our circuit. Every circuit, you've got to like call the main function main, because that's going to be the one that's actually generating the proof. It's also got a nargo toml. So this is for like specifying, the compiler and stuff to use. And if you're wanting to use any sort of Noir libraries and dependencies, you'd pop them under here as well, which we can do a little bit later. But if we have a look at this, this is the example that's in the slideshow. So we're taking in X, which is field, Y, which is a public field. So the verifier knows it, everybody knows it, and we're asserting that they're not the same. We can also write little tests here. So these won't actually be doing any proving. We're just kind of testing that like this actually works. So if we go into here, we can run our tests. We can just do nargo test. And that's going to run everything that has this like test macro on it. Couldn't find nargo toml. I'm not in the right directory. Okay. Oh yeah, like something that I always say when you're running commands, make sure you're where the nargo toml is, because people get tripped up over that. So we'll do nargo test. And then, yeah, this is passed because X and Y are not the same. We can also just like play around with it. So we uncomment this, we comment that one. So now X and Y are the same. We should see that it fails. Yeah, and that'll tell you why, because this is not true. Cool. So now we can get onto some actual proving. First off, we got to actually generate like the constraint system. So we got to tell them what the X and Y variables are going to be. So we can run something called nargo check, and that is going to generate this prover.toml right here. And this has like all of the variables that are going to be passed into the main Noir. And then that's going to be the information that the prover has. So this is like completely client side. This information doesn't go anywhere. It's just whatever I have as the prover. So let's put 1 and 2 in here again. So those are not the same. And then we can actually generate our proof. So if we remember from the slideshow, we got to generate our witness first. And all we got to do there is do nargo execute, and then whatever name you want to call your witness. So I'll say witness. And then you've got a target directory that opens up here. And this is the compiled circuit. This is going to be what we're passing to like different things to prove and verify and stuff. That's what it looks like. And then this is our witness, which looks like this if you try to open it. It's like a binary file. You can look at them in a different way, but the way you're working with Nargo, you don't have to. So now we've like done everything we can with Nargo. We've generated our witness, we've got our circuit, we've written it, we've compiled it, and we can move on to using Berettenberg. And that's going to be our proving system, and we can prove things and verify things with that. We've already installed Berettenberg. We got BB in here. And then we can just use it to prove something. So we'll do BB proof. We're going to pass in the compiled circuit. So we have it here, target main.json. And then we also got to pass in the witness that we generated. So we'll do target witness. It's right here. And then we got to give it like the output of where we want the proof to actually go. So we'll do target. Yeah, and then it's going to be put into target. So you can see here, this is also like a binary file. So it looks kind of scary. We'll see it properly later when we use Noir.js. You can see what a proof like is going to look like with hexadecimals, but this is our proof. So now we have a proof, and inside this proof it's also got our public inputs. So we can literally just pass that over to like Berettenberg verifier, and they can just run verify, which we can do right now. So before we verify, we got to generate a verification key, and the way we do that is by passing in the circuit and an output of where we want the VK to go. So now we have our verification key here, and we're going to use that to actually verify the proof of that we generated here. So we'll just do BB verify, and we'll pass in our proof target slash proof, and we'll give it the verification key as well. Okay. Awesome. That was really fast. So we're using UltraHonk here. That's the default for Berettenberg, and we have verified our proof successfully. So yeah, we can like test it and make sure that if we give it something else, then it's not going to work. I did this earlier because I'm jet lagged. Whoops. Yeah, so little error out, which is good. Cool. So that's like super basics of Noir. We have just written a really, really simple circuit. We compiled it. We generated our witness. We got our proof and we verified our proof. Super, super simple with Nargo, which is really fun. So if we go to step 2, this is going to be a bit more exciting. I've already like created something here, and we're just going to like play around, I guess, with different things that Noir can do. And you can see that it really does feel just like writing regular Rust. So if let's build something like a membership thing where like you're trying to join a football club or something, and it tests that you are above a certain age. We can just do this in a really simple way. We're not going to use like ZK passport, that stuff you're going to learn on Friday, but we can just play around with different types. So say we have like this like global type that's like a person, and the person is going to have, okay, it knows what I'm going to type. The person has like a name. You have to, whenever you're writing circuits, you have to make sure that everything like has a size, because when it's just compiled into constraints, like it needs to know the exact size of the circuit. So you can't have like an arbitrarily sized string or array. So because I'm going to use me here just as an example, we're going to give, my name is Kat. There's 3 letters. So our string has 3 letters. And we can also give it an age. We got different types of integers. We can use U8 here, unassigned integer. What's this giving me? Okay. So then we can also just say like the minimum age. So say we're going to just test that my age is above 18. So we can do like global. This is going to be used throughout the entire program here. Minimum age, that is a U8 as we specified there. And we'll say that it's 20 because it wants me to do 18 and I don't want to listen to it. Whoa. Okay, I clicked the button accidentally. And then in our main, this is our main thing. We're going to pass in like the member, which will be of a type of person. And then we're going to test that they're above the minimum age. So all we're going to do is assert that the member dot age is above or equal to the minimum age. Oh, cursor is so. And then if that's all good, then we're going to be able to actually like generate a proof here. So we can write a test for this. If we do test main, let's say let Kat, which is me, I'm a person. My name is Kat.3 and my age is 27, which happened yesterday. And then we can run main with Kat and make sure this actually works. Oh, I need to specify this as a test. Cool. So if I run Largo test in here in the right place, cool. So I've just joined this club. We can do some other stuff too. So something that's really cool is like passphrases. So the way that you would like prove that you know passphrase is that there'd be a public input that the verifier knows, which is just the hash of that passphrase. You can't like reverse the hash. So they won't actually be able to see what it is. And then you can prove you know the passphrase without revealing the passphrase by just generating like the hash of the passphrase and then proving that. So let's do that. Let's say, so let's take in a member here, and then we're also going to take in a passphrase, which is a field, and we'll take in a public thing as well, which is the passphrase hash, also a field. Oh no, that doesn't go there, that goes here, fields. And then we're first off asserting that the member age is good. And then we're also going to just like generate the passphrase from this passphrase from the passphrase and ensure that that is the same to the one that they actually passed in. So we'll do let the calculated calculated, oh my god, passphrase hash. This is like a tongue twister. And then we can use this standard library to use different types of hashing algorithms. So the one that's really good is Peterson. It's going to be the fastest just because of the way that the Brettenberg constraints work. Peterson is the fastest one to do. So we'll do standard library hash, Peterson hash. This knows exactly what I'm trying to do. And then this takes in two parameters. It takes in takes an array with two parameters. So we're going to do the passphrase and then 0. And then now we have our new calculated passphrase hash. We want to ensure that it's the same as the one that we're passing in as a public input. So we just do this assert thing again. This is equal to our passphrase hash. So let's say we're using this as a passphrase. This is just like a hexadecimal representation of a string. And we can get this passphrase hash by using a test and then printing the outputs. So I'm just going to write it in here and then we can print it in our inner terminal. So we'll do let passphrase. Oh my God, no cursor. It's this, and then we're just going to do what we did here. So we'll do the Peterson hash of the passphrase, and then we're going to print it. So print line. You can print from test, which is good. Oh my goodness, print line, calculated passphrase hash. So then when I go into here and I run Argo test again, I can give it a little show output, and it should show me the calculated passphrase hash. No, it didn't. Oh yeah, right. Don't run that one. So this is the hash of our passphrase here. So we know this is going to be our hash. So we're going to actually use that later. So I'm going to put it in here. And now we can actually test this properly by getting the passphrase. We have here, yeah. Passphrase hash, which we got here. And then we got to actually pass in both of these things. So yeah, the circuit is basically proving that I'm over 18 when I pass in who I am. And it's proving that the passphrase that I know is the same one that is actually I should be using. So if we run the test again, they both pass, yay. Then we can do what we did earlier. We can do Nargo check. And then we get our thing here, and it's slightly different. So we got to put our passphrase hash. This is public, and then who I am as a person, which is private stuff. So we'll just paste in what we already did. Passphrase hash. My age, 27, and my name is Kat. And then we can generate our witness. Spell this wrong. Which is not here. And we can prove it again. We're gonna put the output of the proof. Awesome. So now I have my proof. There's no point in verifying this because you've already seen how to do that. But yeah, it's just kind of like some stuff that Nargo can do, or that Noir can do. Yeah, comparing, and it's cool that you can print stuff kind of like that. So you can do a lot of different testing and things like that. But yes, that's cool. So step 3, this is some more stuff the Noir can do, kind of going into unconstrained functions. So it's an interesting thing to think about when you're optimizing stuff. So basically everything that you put into this function is going to be actually involved in a circuit, and that can get quite expensive when you're writing a lot of code inside circuits. So this is just an example of a square root algorithm. It's the classic Babylonian square root algorithm. which basically is just like kind of brute forcing, trying lots of different things, and eventually find something that is actually the square root of whatever we're trying to do. And if I do this in here, this is going to be pretty expensive. So we can do, go on to step 3. Just make sure this works. Yeah, okay. So this is running the square root of 12. I've actually forgotten how to do. Hold on. Right. So yeah, if you type in Nargo info, you can get like different information about kind of the size of your circuit. So we have 148 opcodes being used here, which really isn't bad, but I think we can get that down. And 17 really ones, but these are the important ones, these ACIR opcodes. These, like, it's not maybe super useful because if you're using different like proving system backends, they will have the different various optimizations for how they work with ACIR opcodes, but it's still, we're going to try to get this done. So yeah, type in Nargo info and you can like get this table of information. And what we can do now is something that's cool about square root is that like you can just square it and you can prove that what it is correct. So we can actually write an unconstrained function for the square root, and then we can constrain the answer in our main circuit. So we can do unconstrained function, it's called square root. It's the exact same as what we have here. So I can just copy this into here and do this in here instead. Okay. And this won't actually be constrained, so there's no proofs being generated here. This is quite unsafe. Yeah, so like be careful when you're using unconstrained functions. You don't want to unconstrain something and then have your whole thing under constraints and accidentally generate proofs when you don't want to. But it's an interesting thing to look at when you're optimizing stuff. So then instead of actually doing the square root in our main, we can just let square root equals the square root is, we call this, and then we just prove that the square multiplied by the square is equal to the square root by the square root is equal to the number that we passed in, and then we can return square root. So whenever you're like actually calling unconstrained functions, Noir is going to give you a warning and it won't let you do it unless you actually mark it as unsafe. So you put in a comment above it and it starts with safety, and then just say, okay, yeah, thanks, Circuit. We're using an unconstrained function. Be careful using in prod. You kind of want to give like a backup of why you're doing it there. And then you need to actually mark it as unsafe in the code so that people are aware. So we're going to wrap this in an unsafe block right there. And now we shouldn't have any warnings. And yeah, this test is going to work the exact same way. It's just saying that we want to like square root 144. We're going to call main. Main is going to call this unconstrained function of square root, and we're going to return square root, which should be 12. So, oh yeah, by the way, we also have for loops in Noir. So you need to specify how many times you actually want the loop to run. You can't just have like a never ending, until I or whatever. You just have to, you can only do it like 10 times. So we're only doing it 10 times here because you only really have to, because we're just going to be using small numbers. Obviously you can do it like hundreds of times. And the cool thing about being in an unconstrained function is that you can actually break stuff. Like you can, whenever this is solved, you can click break and it will stop a loop. So it's a little bit faster, but it's not any more expensive or less expensive because it's within an unconstrained function. So it's not actually within the circuit. Let's run our test here. Cool. We can actually like print our square root as well, so that we can see this is working. So we should get 12 here. 12, yay. That's our thing. And then if we also do this Nargo info again, so before ACR opcodes were 148 and now it's 7. So that's like a huge improvement for this. And it's not having any ACR opcodes for the square root program because it's unconstrained. So we did a lot of optimization there. and it still works, which is pretty exciting. I got 7 minutes. All right, next step. We can prove all this too, but you've seen how to do that. So let's move on. Next up, we're going to be playing a little bit with Noir.js. If you are a beginner, this is the first kind of thing that we recommend playing around with. If you go to Noir, let's go. If you go to Noirlang and go to tutorials, we have like a Noir.js app here. This is a way more simplified version of this tutorial. So I recommend playing along with this first, and then you can watch the tutorial. So we've got our inland index here. We've generated our circuit here. It's the circuit that we've already seen many, many times. We're asserting that x is not equal to y. And then we've compiled the circuit in here, and we've got the circuit in here. So we're going to be able to use that now in our circuit, in our JS file. So the way you got to set it up is you just start a new Noir object, and then we also have backend. We're going to be using UltraHonk for this one. We have other backends as well, as we talked about. And then what it's going to do is it's going to, you're going to say 1 and 2 for x and y. We generate the witness, then we generate the proof, and then we're going to write that proof to a file so we can actually see what the proof looks like. I've just got some helper functions into here, which basically just turns this proof into something that's readable. So you can have a look at that. You have to specify it starts with OX as well, because it doesn't just give that to you. And then we will verify the proof using this proof and the public inputs. So first off, defining our public inputs, we'll just do const input is x is 1, x is not yield. Where did that come from? Y is 2. I'm not going to use cursor for workshops. That's it. That's all our inputs. Then we can generate a witness using those inputs. So we'll do const witness. We call Noir. We execute it. Remember when we did Noir go execute? Then we just pass in our inputs here. Input. And then, yeah, we're already ready to generate the proof. So we do const proof. We call our backend this time because we execute with Noir, and then we prove with our backend, which is our UltraHonk, Rottenberg, pretty much. We do just literally generate proof with our witness, and then we're going to write that proof to a file, and then we can verify it. As simple as it was proved. So we just do const verified. Whoa, is with backend verify proof. I'm passing the proof. This proof already has the public inputs in it. That's the way Noir.js and also Nargo works. So the verifier does have the public inputs, but they don't need to pass it into anything because the proof already has it in it. And then we can just console log whether or not a proof is verified here. So I think we should have a script. If I go into here and run this, it does not work. Oh, I need to install. Okay. Yeah, we're using Noir.js and BBJS. Make sure these are the same. The ones that actually go with each other, because there's loads of different versions of Brandenburg and different versions of Noir. So if you're getting some errors here, it's likely that these are not the same. So just ask in Discord and we can help you out with that. So let's try again. I'll start. Still didn't work. Okay. Okay, so then the way I told you that you're probably getting errors because you're using the wrong versions, that's exactly what I'm doing. All right. This is the right versions here. I think I have to, yeah. All right, I'm gonna have to recompile the circuit. Let's do that. CD circuits, main, execute. Okay. Make sure I'm using the right one. Okay. All right. So yeah, if you get this error, that's awesome. That's awesome that we got this, because if you see this differing serialization formats between ACVM.js and your compiler, it means probably you have some sort of different versioning going on. So I had already compiled this probably in a previous version of Nargo, and it wasn't working. So I just recompiled it, and now we have our proof verified, which is cool. And we can also generate a Solidity contract for this. I'll just quickly show you how to do that. I think I'm running out of time. So let's go to where our Noir.js is. And we have to first, so we generate the Solidity contract with Brettenberg because it's like a verifier. So we need to use Brettenberg for it. So the first thing we got to do is actually get a verification key. So the way, whoops, the way we did that before is we pass in the cloud circuit and the output of where we want it to go. And then we can do write bb write solidity verifier, and we give it the verification key. Target /vk, and then wherever we want it to go, which is our output. So let's just put into target as well. Okay, then. Here. Cool. So now when we head into, all right, never mind. Let's call it contract.sol. Won't work. Okay. All right, here. We have our Solidity verifier right here. You do not need to know what the heck this is saying. But the only important function here is verify. So you can search this, you can just call this from another smart contract. You pass in the proof, the public inputs, and then if this like goes through, that means your proof is verified on chain. So yeah, I think that's everything I wanted to cover. Where's my Zoom?
A
Thanks for
whirlwind tour. Thank you so much, Kat. And if people are anything like me, there's two things that come out of this workshop. One, confusion, because this looks just like regular programming, and that's the idea, right? Like you shouldn't have to think about the cryptographic backend. You shouldn't have to think about constraints really, unless you're doing some really custom things. And so that's one. Hopefully, this looks very familiar to you if you're used to software engineering. And then the second thing is you will probably have a lot of questions, things that you're not quite sure. For example, what unconstrained functions are for, or how they're used, or where they're dangerous, or what exactly some of the things that Cat did do in the backend, and you may want to help your understanding. There's already a bunch of questions like that in the Q&A that the team and I have tried to answer in parallel to Cat's workshop. But this is, if you have a question like this, just post it in the Discord. This is a great, this is what this month is also for. Highlight things that need explanation, and there's definitely going to be people around that will be happy to jump in and try to help you understand all of this. Yeah, the last thing is, it was Kat's birthday yesterday, so a very happy birthday, Kat. Unfortunately, you probably don't want to be in the 27-year club. If you look that up, I don't think that's a particularly nice club to be in, but let's not have morbid thoughts. Yeah, it was a very short amount of time for a workshop, so I really appreciate you taking us through all of that in such a short amount of time. It's all going to be recorded. If you want to watch it on 0.5x speed, you'll be able to after this call.
Cool. Thank you, Kat. I still
Thanks,
can't get
guys.
the animations. Gotta configure that later. But yeah, thanks guys. This was a great first workshop. We have another one tomorrow. And yeah, for some of you guys asking questions in the Discord already, try to ask in the help channel if possible. And again, like if you don't have visibility into the channels, you need to go to the Get Roles channel first and then mark that you're a NoirHack participant. Then you'll see all the NoirHack specific channels to ask questions. And then try to put like questions and help. And then try to put an introduction as well. And yeah, tomorrow we'll have a bit more on the tracks and then also on team formation. But yeah, I think we can end it here, and then I'll see you guys tomorrow for the team formation and tracks chat.
Thank you
Wait,
all.
can I say something? Can I say something?
Go
Feel
on,
free to
go on.
tag Josh, me, Salil, or James in the Discord if you've got a question, so we can get a notification. Especially if it's anything about what I just talked about, just tag me at Cat.
That is a very generous offer from Kat. I will say, do it responsibly, please. There are a lot of people in the Discord, and if you happen to be really well versed in Noir and you want to help people out, and you see people having questions that you know how to answer, please also jump in. That's greatly appreciated. Thanks,
Yeah, if you
everyone.
know how to answer, please answer. Try to be as collaborative as possible and help others. Bye, guys.